Understanding the basic concepts in radiation physics is important in understanding how X-rays are produced. I'm going to share some on radiation physics, then we'll get to the X-ray machine and the production of X-rays. Let's begin with the atom. An atom is a fundamental unit in matter. Atoms have a nucleus and orbiting electrons. Their nucleus consists of protons and neutrons, and then the orbiting electrons. The amount of protons it has is equal to its electrons. That would mean that that atom is stable or balanced. When it loses electrons, it becomes unbalanced, and we'll learn about that on the next few slides. Electrons are tiny and negatively charged particles, and they travel around in their distinct paths. We can call these shells or orbits. And it requires a lot of energy to remove or break off an electron from its shell. The amount of energy that it takes has to be equal or greater than the amount of energy that's actually holding them on or near their nucleus. If you see the farthest shell to the nucleus on this image, those are going to be the weakest. The closest shell to the nucleus is going to be the strongest. When we lose or gain an electron, it leads us to ionization. That brings me to ionization. Normally, most atoms are neutral, meaning they have an equal amount of protons and electrons. But if an atom is incomplete on the outer shell, it will try to attempt to capture an electron from another atom. When we shoot energy towards the atom, or enough energy, it ejects the electron that shoots off of it. The electron that shoots off of it becomes a negative ion, and the remaining atom becomes a positive ion. So the energy that particulate radiation creates is called photons. Photons are bundles of energy with no mass or weight, and they travel as waves at the speed of light, and they move through space in a straight line. This image is just showing a good visual of what increasing wavelength look like with the frequency and our increasing energy. X-ray is up on that list where it has very, very short wavelengths and high frequency. That is what we want. Okay, so that gets us to the X-ray machine. Dental X-ray machines may vary somewhat in size and appearance, but they will all have three components that are the same: the control panel, the extension arm, and the X-ray tube head. Our control panel has on and off button, indicator lights, exposure button, and allows us to change the time, the kV and the MA, so that we can regulate our beam. The extension arm, it suspends our X-ray tube head and houses the wires that go from the control panel to the tube head. It also allows for movement and positions of the tube head. Okay, last but not least, we have the X-ray tube head, which is housing our X-ray tube. This tube head is also called a heavy metal housing, and inside this housing is insulating oil that surrounds our X-ray tube where X-rays are produced. Here's our X-ray tube within our X-ray tube head. Our tube head is lead-lined for protection. X-ray tubes consist mainly of two parts, a cathode and an anode. And in that cathode, we have our filament wire embedded in a molybdenum focusing cup. It is negatively charged. Across from that is our anode. Our anode is a tungsten target that's embedded in like a copper stem because copper is a good conductor of heat. When electricity from the wall comes into our X-ray unit, the current is directed from a filament circuit and the step-down transformer. Our filament circuit is using 3 to 5 volts to heat the tungsten filament in the cathode. This is called thermionic emission. You can just picture a bunch of electrons in a cloud. The electrons will stay in that electron cloud until the high voltage circuit is activated and the exposure button is pushed. The molybdenum cup in the cathode, it focuses the electrons towards the tungsten target in the anode. And when the electrons strike the tungsten target, our photons are created. 99% of the X-rays produced are absorbed as heat, and 1% is converted to X-rays. This is all happening within less than 1 second. Some of the X-rays from the 1% of X-rays that weren't absorbed, they travel through the unleaded glass window portion on the tube. They then will continue to go through the tube head seal and the aluminum discs. Those aluminum discs are filtering out the longer wavelengths that are less penetrating. And we can restrict the size of the X-ray beam by a lead collimator, and the PID is also lead lined. This helps the beam to be directed directly to where the operator wants those X-rays to go. The X-ray beam then exits the tube head at the opening of the PID.